Okay, next up, we have Gonzalo Diaz, Senior Project Manager at EPAM, joining us from Bogota. And he has walked that tightrope at EPAM, helping regulating industries adopt DLT without breaking the rules and losing their edge. And if you guys ever faced pushback like blockchain is too risky to our business, this talk is definitely needed for you. Welcome on stage. The floor is yours.
Thank you very much for the introduction. Thank you everybody for attending the presentation. So my goal today is have a conversation or share something that I've been working for some time, understanding this type of technologies, which are permission blockchains. So for today, just before we start, I'm going to use we're going to do a small exercise with Menti. This is the QR. If you want to participate, please use the QR code or the link that it's in the screen or the code to access the Menti. So for today, the idea is to go through a market overview, trying to understand the market for this type for blockchain in general and this type of applications or platforms. Some things regarding blockchain technology, not too much in depth about blockchain because it is, even though it's a presentation about one type of application of blockchain, it is not going to be intensive on the blockchain's part of the technology, mostly on the use case. Then we're going to go through permission blockchains, some potential applications and use cases. So let's talk about the market view of blockchain technology. Before we start talking about it, I would like to share a reflection or an idea is that our understanding of reality depends on the lens we use to observe it. It all depends on how we see problems, how do we see markets, technologies. Depends with the lens we use. That's the way we apply it, and that's how we discover use cases, applications, or take the technology to solve real problems. So I want to play a game with you, and it's the Menti that I will be. Give me a minute. Good. We have a lot of things. We have a lot of things. So thank you to all that are. Sorry, I just kind of under the weather with the cough. Apologize. So we see the one that is bigger is crypto, assuming cryptocurrencies, decentralization, ledger security, smart contracts, privacy regulation, token. Those are Bitcoin, memecoin, efficiency, DeFi, technology, programming. Very interesting um, ideas and words that come to your mind. Thank you all for sharing that. So after we see this, it's kind of a small experiment that takes me to this. How is the world looking at blockchain? During the last 5 years, web search trends shows that the world its interest around blockchain is heavily correlated with cryptocurrency. If you see the chart that we have on the left, we see the search trend from Google about blockchain, cryptocurrency, private blockchain, public blockchain, hybrid blockchain. There is an evident high correlation between the blockchain, the searches for the blockchain term and cryptocurrency. And if we contrast that with the chart on the right, blockchain with any other, with the main platforms for cryptocurrency, I think there's no need to to see. there's there's very high correlation between blockchain, Bitcoin, Ethereum, Solana. So we can start to see that there is a link between the two concepts. The market understands in general, or in a huge portion of itself, blockchain with cryptocurrencies. The same applies when you see the search around the world. You see that US, Canada, Australia, some part of Africa, India, Middle East, there is a huge emphasis on cryptocurrency. The rest of the world is basically looking blockchain. In There's no evidence in the chart that you're seeing that either private blockchain by itself, public blockchain, or hybrid blockchains are part of the main interest around the world. So it's not that it's not being searched, but it's not the mainstream concern when you talk about blockchain technologies. So we can say, I think, we can say without fear of misinterpreting the data, that blockchain is assimilated by most of the market as cryptocurrencies applications and related applications. So that led me to the question: are we all victims of herd mentality as a market, as an industry? Are we only looking? Are we looking the problem or the application or the technology itself through a very narrow lens? So that's why we started looking at the technology landscape under the premise that there is more that meets the eye. So it's taking a broader view about the technology without assuming anything and without considering the usual applications that comes to mind as the first reaction that we see, even in the small exercise that we did. So today, blockchain implementations or the implementation of the blockchain technology differ mainly in the nature of the network in which they are deployed, extending the scope of applications that derive from its initial implementation. We all know the origin of the blockchain technology. It started, everything started with Bitcoin. So that was the initial scope, and I think that's why we are all linked on that application. When Bitcoin was released, it kind of locked the industry into that. Not all, but most of the industry and a lot of people is just following the hype. So in terms of network types, you see that there is one type which is the most known, and it's part of the mainstream mindset, is the public type of networks, which has the usual suspects: Cardano, Solana, Bitcoin, Ethereum, Binance. But we are starting to see a second type of network, which are private. In that area, we have Hyperledger, Iroha, Indy, Fabric, R3, and Besu. And there are some others that are obviously in the middle. You have the two extremes and some things that are being worked in the middle where the two sets intercept. So public blockchain is basically, we know the story. They were first introduced by Satoshi Nakamoto, the mythical Nakamoto, in 2009. The key characteristics of the public blockchain is that they provide open and decentralized network or spaces when transaction can happen, security and incentives to be part of the network in the form of minting that comes as a reward for taking part of the minting process of the blocks in the blockchain. The typical use case I think we all know about them is the decentralized digital currencies, which was the first application with the corresponding or the subsequent logical applications, which is P2P payments, smart contracts, decentralized applications. We also have non-fungible tokens. We have decentralized finance, DeFi. That's another huge area. And we have the decentralized autonomous organizations or DAOs. And they came in waves. The first wave was the decentralized digital currencies, P2P. Then we started seeing more complex applications or use case that went kind of beyond the initial scope, and we started seeing networks like Ethereum. That was the second wave. And after that, we have NFTs, DeFi's, and DAOs as a consequence of the evolution of these type of networks. But then you need to start thinking, or we need to start thinking, are public implementation good for my enterprise applications? Are they suitable? What if privacy is key for my use case? Because we're thinking about implementing things in public networks with information, with copies of information disseminated around the world. Because public networks are not anonymous. They are not anonymous, and they do not guarantee privacy. What they do is they have they have a layer of abstraction, but you are still a user and you still have an identification, and that can be tracked to you, and the information that you share in the network can also be linked to you. Am I willing to share control? You're in an open network where there is no control. So is my application sensitive to this type of lack of control? And that's why private blockchains started to be developed. They were first introduced by IBM in 2016. Key characteristic of this type of blockchains is, first, they focus first and foremost in data privacy. First, then close control and centralized network, which allows companies and enterprises to define their rules and control the environments and the rules by which the users and or the agents that transact through these networks interact. Security and simpler consensus mechanisms, because we know that one of the key problems of the public implementations of blockchain is that every day the consensus mechanisms and the methods that are used to mint and to create and to set and to reach consensus on what it's going to get into the blockchain, they are becoming more expensive by the day. And there has been some advances in that regard. Some forks have been made in some networks, but they thought as well on simpler consensus, because as you are having a private network, you can have simpler type of consensus mechanisms. So, what are permission blockchains? It's basically a way of expanding the scope of application of public blockchains by adding constraints. It's very rare, because usually what you see or what you think is that expanding scope means reducing constraints. But in this case in particular, for me, it's very fascinating because you add constraints, and adding constraints allows you to do things that you cannot do with the original one. So what are they? They are restricted networks where only authorized participants can access and validate transaction. Basically, they are usually controlled either by a company, by a conglomerate, or a group of agents that agree on some rules for the network. One of the key elements for this type of networks is the access control. The first form is that it implements permission access, that only authorized participants can join the network. That's important, and access the data. That helps guarantee privacy. This control limits the exposure of sensitive information and ensures that only trusted entities can participate in the network. The second part is, or the second pillar is role-based permission, that it's tightly linked with the first one, is that you can, in a single network, you can have different agents having different roles, different levels of access to the information, which helps also materialize privacy, which is not possible by itself in the public networks. Another key pillar is confidential transactions, which is implemented in two ways. First, zero knowledge proofs that allows that one party to prove to another that the statement is true without revealing some information about the transaction itself. It allows to have the restrictions allow to implement this type of zero knowledge proof that comes from the trust that emerges from private networks. The second, let's say, area, it's private smart contracts, which is an implementation that is already presented, or it's already there in the public networks, but it all revolves about private contracts and rules that are agreed upon when the network is created. Another key pillar is the governance and compliance. You can have on-chain and off-chain storage, so it's not like in public networks that you start putting a lot of information on the public blockchain. Here you can have information on the chain with the corresponding privacy controls and access controls and that guarantee privacy, but you can also link it with off-chain storage, which expands the applicability of this type of networks. Another one is the selective disclosure, in which people can choose the type of information that is shared between the parties. So you share the type of information, or you agree the type of information that will be shared in the context of a transaction or a set of transactions that happen in an industry, in a business relationship, etc., etc. Another thing is isolated networks. You can have implementations that have segmented networks or channels, or that allows you to have stricter control on the access in the level, in the even in the network level, not only in the logical level or in the access layer, like having role-based access controls, and so on and so forth, but also through the network configuration, which is something that is very important. Another one is you can have centralized governance. As you are owner of the network, you set the rules of the network. You can control how the network is configured and behaves, and you can change the way it acts throughout its life. Not what is happening with Bitcoin, which you cannot change the initial configuration. Finally, audit trails. You can keep track of anything that is going on in the network for auditing purposes. And finally, the final pillar is that these type of networks are customizable. Customizable in the way of availability of different types of consensus mechanisms, which gives you flexibility on the type of implementations and the type of use cases that you can implement under certain conditions or constraints. So basically, you can implement things like Byzantine fault tolerant algorithms. You can use RAP, you can use proof of authority, and you have protocols for interoperability, which allows you to have connections between different private blockchain networks, which is fascinating also because you can have different agents or group of agents with their own networks, but they can interact and they can connect between them, which explodes the level of sharing that you can have while keeping control of what is shared. One example of this is the Hyperledger Fabric, which was one of the first private networks that were open source. IBM developed it as an internal project, but then they open sourced it. In this type of networks, you can have, in this case, an example. You can have many organizations. In this case, organization 1, 2, and 3, and those organizations, they get together and they agree on a channel configuration setting. So they define it, they implement it, they already have the infrastructure there. And with that configuration, they implement the certificate authorities for each organization. And then that translates into a channel, which is, let's say, the mini network or the specific network that is created as a consequence of a channel configuration. When you have that channel open, then you have, and this is something that is very interesting about this type of networks, you have a type of service, which is the order. In here, you have the ordering of the transactions in the blocks is separated from the consensus. So in this case, you have at least one agent that is getting all the transactions, putting them in order, and getting blocks ready to be to be moved through the consensus mechanism and then um, added to the layer. So at that moment, the network or the organization one creates the first version of the layer, which is ledger one. And that order connects to the channel, and then the other organizations take the initial ledger L1 and they make a copy of the ledger with their corresponding peer services. The same happens with organization number 3. In this case, we only have one order. Once they are connected to the network, we can start adding applications to the channel. It's not only the agents that connect, but you can also have open APIs to connect applications that run the contracts, which are S5. In this case, you only have one contract, which is S5, and you can run the contract through applications, through open APIs, that you can implement many things or different types of interaction with the contracts. And each agent can have their own set of applications. And this is only one. Then you can have multiple channels and organizations connected differently through multiple channels. Some potential applications. All of this leads us to rethink some traditional approaches. Potential applications, you see things like supply chain management, financial services, healthcare, identity and credential management, government and public sector, and other applications. In supply chain, you can have things like provenance tracking, cold chain monitoring, customs and trade documentation. Financial services, you see things like syndicate lending, know your customer, sharing that information between financial service companies. Central bank digital currencies, This is one of the main approaches that are being used when exploring this type of currencies. Uh, Derivatives clearing, healthcare, you have clinical trial data sharing, pharmaceutical supply chain, which is supply chain controls, insurance claim processing, digital identity wallets, educational and professional certification. This is very interesting use case. Immigration and visa systems. Government sector, you have land and property registries, tax compliance, and VAT, value-added tax systems, digital voting system, welfare and benefit tracking, energy, environment, manufacturing. The sky is the limit. So you see a lot of things that are in the realm of real businesses. I would like finally to share, just to close this and we open the floor. One of the first use cases I saw when I started looking at this phenomenon, which is the global food supply chain. This type of supply chains, they have a huge problem, which is ensuring the trust and traceability across the supply chain is very key. It's key and critical to protect public health and corporate integrity. So the challenge, and here I'm taking the US market. In the case of the US food and safety system, it's basically a globalized supply chain. You have food coming from all over the world, and ensuring traceability is key to control and to protect the market. In context, just for you to know, in 2000, there's regulation in the US about food safety that was regulated in 2011. Just to give you some numbers, in 2023, the FDA evaluated 69 incidents, responded to 25, and issued advisories for 10 foodborne outbreaks. And those came with people getting into the office and to the office, sorry, to the hospital, and even dead, and even died. The typical cost of a single food recall in the US, it's around $10 million. The US food supply chain moves food from all over the world, and the investigation of this type of diseases is very tedious and can take a long time, with lives being put at risk if not resolved fast. So what happens in in the food supply chain? You have the farmers, you have agents in the middle, which is they can take the form of transport companies, storage. Then you have some processing, and you have other agents in the middle: transport, storage, the ports, the customs agents, the customs offices. Then you have distribution, which is the local part. You get the product, and you can have several steps before you reach your destination, which is the retailer or the final customer. So throughout the entire value chain, you have risk of contamination, tampering, even terrorist attacks can happen and have happened through contamination of food-related supply chains, water. All it's part of the risk nature of this supply chain. So imagine that you can have something that goes across the entire value chain that guarantees openness, enterprise grade application that give you permission networks, segmented networks, that is customizable, that is tamper proof, that can have access control, provide transparency while ensuring privacy, and provides fast answers to problems that arise in the value chain. So there's a public, and this is public information. There's a huge success case for this type of networks, which is what Walmart did in 2026, in which they implemented two POCs using Hyperledger. Actually, it was Hyperledger Fabric to trace mango sold in the US and the pork that was sold in China. They require enterprise grade and permission platform. The sources are in the bottom if you want to check them. They're they have been published by Walmart, by IBM, and the Linux Foundation. The The key results is they were able to reduce the time to process incidents in the mango value chain from 7 days to 2.2 seconds. Imagine that, 7 days to 2.2 seconds, to provide answers to the regulators, to provide answers to the clients, to reduce risk of harming people, and to see if your product has a problem or not. If not, you can just keep selling and you avoid losing $10 million in average for each recall. In China, they started adding the certificates of authenticity of the pork to the blockchain, providing transparency to the entire pork value chain in China and reducing cases of fraudulent pork meat. The current state, as published in the latest report from Walmart, is that by 2028 they reach 25 products being tracked globally using this network. And they announced that all suppliers of fresh leafy greens will be using this blockchain system in 2029. There's no public information regarding if that has been reached or not. So with this, you see that blockchain is not just a technology, it's an engine of trust. In a world where safety, transparency, and accountability matter more than ever, these type of networks can help us redefine how we protect people, products, reputations, um, and creating better value chains and better businesses. Thank you. This is the end of my presentation. I'm open to.
Thank you so much, Gonzalo. I unfortunately we can take only one question now because we are very short on time.
Oh,
Uh, Here goes the
perfect.
most interesting one, I believe.
Okay.
If you could go.
If Walmart can mandate suppliers' participation, what happens when smaller farms lack resources to join the permission system? In this case, it's a matter of taking it outside of that example. As you have open implementation, you have a standard interconnection protocols, everything it's open. You can also, as part of your implementation, supply this type of applications, because in the end, what you need on the let's say in this particular use case, and this is my personal view, you just need to provide, let's say, the farmer with a mean to interact with your network. They do not need to have the copy of the network. Maybe they might want it, they might have it online. It's a matter of implementation. So it all depends on if you are trying to do that and you're targeting small business owners or small farmers. Obviously, you might need to include that type of application facing them as part of your investment. And it's some things that happen in other industries and with other type of applications. Those interactions or those investments can be absorbed by the agent that has the resources and the interest to control the value chain.
All right. Gonzalo, thank you so much for your valuable insights into permission blockchains and yeah, their impact on the global food supply chain. Also, thank you for sharing the insights with the Walmart. That was very interesting to hear.
Thank you all
You're
very much
very
for
welcome. Thank you, Gonzalo. You're very welcome for our brown bag sessions here on our monthly basis. I will send you the invite separately. But for now, we're very short on time. And thank you so much for joining once again.
Thank you for the time. Have a good rest of the day.